Greetings and welcome to Code Quickie. And today we're going to be looking at predicting bike trip duration with regression model BQML. Well, the first thing is about models, right? There's many different types of models, and the basis to our model is connecting our data to prediction. Now, behind the models, what we have are the scientific logic that goes into play. Some things they're called regressions, sometimes they're called classifications, sometimes they're called recommendations. But basically what we have is for different types of data, we want to use a different type of machine learning because not all data is the same. Say for example, if you're trying to figure out whether a plane will arrive on time or not, the logic this question is a yes or no question, other than consider the stock market, saying if a stock does well on this day, how much will it go up by? Will it go up by 20%? Will it go up by 50%? Will it go up by 100%, 200%? And there's a much more factors that go into play. And you see, you can't just use the same approach for different learning, because although some answers are yes and no, others answers are more open-ended. So today we're going to be seeing how we can get yes or no answers with BigQuery, right? BigQuery, as you know, in data science and Google Cloud platform, BigQuery is really the basis. It's the foundation. It's the building block. If BigQuery is not in your project or not anywhere in your pipeline, in your design, in your workflow, then something is missing, right? And another thing. Another thing, that very important thing that we want to just go over before we start this lab is that as you're watching this video, I want you to focus on models, because models, they look threatening. They look like this machine learning part that you really have to know much, but the machine learning that you have to know, you don't have to know. Models are just another form of a table. They look like SQL, and they look like you're putting together a table, okay? And they're straightforward, but very, very important. This is how you could get your machine learning done with models. If you know how to make a model, you're halfway, or even more than halfway with your goal with machine learning. So let's go ahead and get started. So first thing we're going to go and do is, right, we're going to give yourself a set of data, right? We're going to need data that says, hey, let's look at this data. Let's try to make a prediction, because you can't make a prediction without having any data first. So the first thing to machine learning is using data. So we're going to go ahead and run this query. Okay, and right now we want to figure out if the station, right, if the station is related, the name, the location of the station is kind of related to the duration. Basically, we're trying to say if people are going to use their bikes longer at Serpentine Car Park over at Gunmaker's Lane, and since this data is in EU, probably processed in EU, we're going to go ahead and explore it with Data Studio. All right, I'm going to give myself a column chart like so. I'm going to increase the bars to 100. I want to look at more data, and then instead of my record count, just to see how many times they appear in my data, in my table, I'm going to check by duration. It's going to load. And we see here that there's not a correlation. There's not something we could say. We can say, right, that, all right, if you're in Stewart's Road, right, people use their bikes longer, but this will actually create people are regular, day-to-day interactive with starting learning or starting how to use BigQuery and Data Studio. But in a real-time business setting, right, you have to decide where the bikes are being used the most, right? You have to decide where to send your resources and your materials and spend most of your time and send more bikes to, and you have an outlier here. But after this outlier, right, it really doesn't tell you. It basically says, hey, you have to send your bicycle to all these areas, and you have to send them, right? It really doesn't tell. It tells you to send them to a few areas, and it probably doesn't tell you really what's going on. It's hidden information. So all you do, you want to look at another piece of data. So instead of looking at the station where the bikes are, we want to go ahead and look at the day of week that the bikes are being used. Go ahead and run this query. It's not too obvious from here, but we could go ahead, explore it with Data Studio. Take out your good old bar chart, and then instead of record counts, which just counts the items by each, where you can go ahead and count by day. And then we see now, I had a little bug there, which I tried to call them by week sevens, but these are actually the days of the week, right? So 7 represents Sunday, runs represent Sunday, 7 represents Saturday, so on. You can see from here that on the weekends, bikes are being used more. Zoom. And if we change that query again from day of the week to hours in a day, and we could look and explore our data, right? Visualize our data. Let's go ahead and change the metric, right, to duration. Now looking at how many times 1 p.m. appears in our data, where you want to see the duration. Let's show that hours. Search style 224. Right, we could see that in the early morning, let's try to restart this. Where we could see that at night, apparently, people want to use their bikes more, right? That might be a little data filtering at 1 a.m., 2 a.m., 3 a.m. You think that people are sleeping, but apparently, people in the EU like to ride their bikes out when it's nighttime. Probably go see a friend or two. Or there's a curfew and they can't use their car, so they're using bikes to see their friends instead. Or it's too windy in the morning and all the dust is everywhere. There's too much traffic, so they rather not. Strange reason. Otherwise, you want to go ahead, if you feel that's strange, want to go ahead and do some data cleansing. Make sure that your data sources are giving you the correct data. Other than that, that's outside the scope of this video. And what we can see is that in the morning, right? In the morning, in the overnight shifts, really, right? We want to let people use the bikes. We want to let people use the bikes. And in the early morning, our crew doesn't have to do overnight. That's better for our crew. That means we can hire more people with less pay to go ahead and do maintenance on these bikes as needed. So now we want to do is, okay, now we have our data, right? The data that we want to look at, the data we want to make determinations from, the data we want to work with, right? This is known as our training data. This table right here that we have set up right here is our training data. And this is the first part of a model. This is the first part of the model, right? And the second part of the model is deciding what are we going to decide on, as well as the features that go into that decision, which we're going to go ahead and see it soon. However, want to take a look at another feature, another metric. Want to see if, like, the number of bikes. Want to see the number of bikes at each station and see if that impacts the duration. We want to see if the number of bikes at each station impacts the duration. Say if there's like 2 bikes at one station, obviously the duration is going to be less. If there's 20 at another, duration is going to be more, right? And there's less bikes, longer duration, less bikes, shorter duration, right? We can make a decision whether or not we need more bikes in stations, and we should take bikes away. We'll go ahead, look at the graph. Always love how it gives you record counts first. That's okay. Want to see the duration. Then you want to sort by ascending. Then you want to sort by bikes count. Want to sort that by ascending. Want to go ahead, give our style by 100. Right, and right, it looks like we can't rely on this data because apparently if a bike has 1 or 2 stations, right, and if you think about it, that's just one person using it for what the amount of time, which is this amount of time. However, if there's 27 bikes at a station, amount of time is same because there could just be 27 people using it. So the average duration would average out just the same as 1/1. So 1 divided by 1 is 1 times the duration, average duration is 1, and 27 divided by 27 or so is 1, like the average duration, like so. All right, and then 58, you could try to determine what's going on here. Are there just people using the bikes for longer? And it seems like that is so. That must be a major hub. So wherever this 58 is here, right? Right, you could say, we could try to conclude that this seems to be like an outlier. We don't know one where there's more stations or there's more bikes, because you look at 46 right here, and people are just not using it that much. So we really can't rely on this data, right? So we're going to go ahead and take the time to take our model, all right? And we can do so. In order to create a model looks like this. So we have the table that we're working with, and then this syntax, don't be too afraid. All it's saying is that change this date time into a string, right? We need this as a string. We need this as a string because when we put our tables into models, they only accept ints, floats, and strings, right? So we just take it, change it to string, right? It's just new SQL, so just a SQL syntax that we're learning. Nothing too scary, right? Take a look here. This is going to be our training data set. And this right here is our actual model that we want to go ahead and work with, right? So model, I just showed you the training data set separate, right? This is our training data set. This is actually a table, okay? And our model, okay, looks like a table here, right? Where this is our training data set, right? This might as well be another table, right? You could go ahead and say, from our custom training data set, right? This whole statement right here, very important. Might as well been the table, right? But most importantly, the table of the data you want to look at, right? So we want to look at the options, right? Input label, we're trying to learn about the duration, okay? And the model type is linear and regression, right? Linear regression. Yes or no. Answers yes or no questions. So what you're going to do, go ahead and run, right, we get a little error, right, because I don't have a data set that exists, right? I don't have a bike model data set. Go ahead and delete this data set, and I'll delete it later. Let's go ahead and create a data set, bike model, and a data location, give it European Union because we're dealing with those bikes, especially from Great Britain and the like. And now this model is going to take a while to run, right? Because we're giving it a table and we now have to train it. We have to train it to see from the table where the duration, where in the day of the week, the duration is going to be longer or the duration is going to be short, right? Right, so after our model is set up, as we can see over here, what we want to do is we want to head over to the schema. And now this is helpful when we make a prediction, right? So the model is set up to make a prediction based on what data it was trained off of, the training data set. As you can see here, the training data set we gave it was the start station, the day of the week, and hour of the day, and it was supposed to come to conclusions on the duration based on these features. So now when we go ahead and try to make a prediction with this model, right, these features have to match up. We have to have logic that match out to the start station name, right? We need to have logic that match out to the day of the week, and we need to have logic that match out to hour of day. Only then we can go ahead and make a good prediction. So let's go ahead and run this. Let's see predictions that we get. You go ahead and explore this data studio, and just to map out the predictions that the machine learning model makes actually match out to what we see here. And I think this is the bike account. Let me just resume this to the hours. Right, highly unfortunate, but in our prediction, right, our predicted duration, this is what with new data, or we're practically using the same data, right? But if we had a different table, we could go ahead and predict, right? We predict, right, week 1 or week 7, and compared to the actual is like so. And now if you wanted to go ahead and change that, and we wanted to go and say, we would look at the hour of the day, right? And then we sort by the day of the week, we sort by hour of the day. Right, we can see that, right, our machine learning model is a bit off, right? So there are some ways to optimize this, and I'll leave it in the description. But for the most part, right, if you just go back to day of week, right, we can see that our prediction is accurate enough in order to make similar conclusions, right? So basically, which days will like share the utmost, right? On days 1 through day 7, and then on which days, right, should we go ahead and do service, right? Day 3, even though it says week 3 here, it's actually day 3, right? And that is that. And there's many things we could go ahead and do. Obviously, I'll paste the link in the description as the instructions to this workshop, as well as ways to go ahead and upgrade that model so it can go ahead and be more accurate in its results. Right? So that is how we work with machine learning. That's just an overview of what machine learning is really about and how to go about it with Bitcoin. So thank you for watching. Please like, share, and subscribe.